Welcome to all for today's session. We are already watching two videos. Here we are going to see another topic in the fundamentals of UAV. The topic is nothing but the control from command as well as the unmanned aircraft systems. Here we are going to see the control and the communication systems. This control and communication systems form the nervous system of an unmanned aircraft system, which is called UAS, which ensures the safe, reliable, and efficient operations of the unmanned aerial vehicle across various mission scenarios. These two subsystems, control and communication, work in tandem to provide the real data command, the data transfer, autonomous decision making, and feedback monitoring. The control system is responsible for managing the flight dynamics of the UAV through autopilot algorithms, sensor integration, and actuator responses also. On the other hand, the communication system acts as a bridge between the UAV and the ground control station, ensuring the seamless data exchange. Next is telemetry feedback and a remote command input, especially in beyond visual line of sight operations. Starting with the control system, it can be broken down into three primary layers. One is the inner loop control, outer loop control, and finally it is mission level control. The inner loop control focuses on real-time stability and responsiveness of the UAV, such as altitude, velocity, and altitude regulation. Through proportional integral derivative controllers or more advanced model predictive control algorithms. This layer integrates sensor feedback from inertial measurement units, barometers, magnetometers, and GPS to maintain the orientation and position. The outer loop control governs the navigation and trajectory tracking, ensuring that the UAV follows the waypoints or predefined flight paths with accuracy. Mission level control handles the broader tasks like object tracking, dynamic replanning, or multi-drone coordination. And often it leverages onboard computing systems running artificial intelligence or machine learning algorithms for real-time decision making. The ground control station GCS plays a pivotal role in controlling the control by the interfacing human inputs to the UAV's onboard flight control. It allows the operators to define flight paths, adjust control parameters, trigger payload actions, and receive status updates. Control commands sent from the GCS include takeoff, landing, loiter, return to home, and payload activation, all of which rely heavily on the robust communication. This brings us the communication system, which is typically composed of two types of links: command and control link, data link. This command and control link is essential for transmitting control inputs and receiving status updates. And it must be secure, low latency, and highly reliable. In contrast, the data link handles high bandwidth transmission, such as live video sensor, payload data, as well as the imagery, that image photography. The UAS communications often operate in different frequency bands, like 2.4 gigahertz and 5.8 gigahertz, depending on the range bandwidth needs and regulatory guidelines. Line of sight communication is common for short range UAVs using the radio frequencies between the UAV and the GCS. For long range missions, beyond line of sight communications become critical. In such cases, satellite communications using geostationary satellites or cellular networks such as LTG as well as 5G are utilized here to maintain the uninterrupted data flow. SATCOM provides global coverage with increased latency, while 5G offers a high data rates with low latency, making it suitable for real-time control and live video streaming. Modern UAS employ redundant communication systems to enhance the reliability. For instance, in the event of a primary link failure, a secondary backup link can take over. Similarly, frequency hopping spread spectrum and a direct sequence spread spectrum techniques are used to counteract for signal interference, jamming, or hacking the attempts. So communication protocols such as the MAV link are called a micro aerial vehicle link. They are widely adopted in the both commercial and open source UAV systems for sending structured messages between UAV and GCS. Security is an equally important aspect of control and communication systems. Since UAVs can carry sensitive data or operate in critical areas, encryption standards like AE256 are commonly implemented in communication channels to prevent the unauthorized access. Cybersecurity strategies also include digital structures, authentication tokens, and secure both the mechanisms. Another crucial component is the telemetry system, which allows the real-time monitoring of UAV parameters such as the position, battery voltage, signal strength, airspeed, and sensor health. This feedback is visualized at the GCS interface, so helping operators make informed the decisions and take corrective actions during the anomalies. Telemetry is often transmitted at the lower frequencies than the payload data, as the periodic stability is occurred. So that's all about the control and communication systems in unmanned aircraft systems in police system. So we will deal with another topic in the fundamentals of UAV in the next class. Thank you all.